Hello guys, in today's video we are going to discuss the solution of the problem print n-bit binary numbers having more ones than zeros. So let us look at the problem statement. The problem statement says that given a positive integer n, your task is to generate a string list of n-bit binary numbers where for any prefix of the number there are more or equal number of ones than zeros. The number should be sorted in decreasing order of magnitude. So let us try to understand the problem statement with the help of an example. So let us take an example where n is equals to 2. So this simply means we need to generate a 2-bit binary number. So the 2-bit binary numbers which can be generated are, so these are the 2-bit binary numbers which can be generated. Of these 2-bit binary numbers, let us generate the prefixes. So here the prefix are 0 and 0, 0. Here the prefixes are 0 and 0, 1. Here the prefix is 1 and 1, 0. And here the prefix is 1 and 1 and 1. So these are the prefixes. If you see in these prefixes, this is not the string which we are looking for. The reason is the prefix over here, if you see, there exist no ones and the number of zeros exist are 1 or 2. So in this particular case the condition is not satisfied, because of which this is not a valid string. This also is not a valid string because over here if you could see this prefix does not contain any 1, whereas this prefix contains a 0. So here the number of ones is not greater than the number of zeros, because of which this is not a valid prefix. These two are valid strings because for all the prefixes which we could generate here, the number of ones is greater than the number of zeros, because of which for this particular case our output will be 1 0 and 1 1. So that's about the problem statement, folks. Now let us go ahead and discuss the optimal solution for this problem. So in order to discuss the optimal solution, what we are going to do is we are going to discuss the solution for n is equals to 1, and then we will go ahead and keep on increasing for n is equals to 2 and so on in order to achieve our answer. So for n is equals to 1, we know that the valid string is 1 only. So for n is equals to 1, the possible strings are 0 and 1. Of these two possible strings, the valid string is this, the one which satisfies the conditions given in questions. So for this case, the valid answer is 1. And over here, let us have these values populated also, which is the number of zeros in this string is 0 and the number of ones in this string is 1. We will be using this information, that is why I am populating it. We will see it in a bit how we are using it, but for now let's proceed forward. So for n is equals to 2, let us go ahead and generate all possible strings. So for n is equals to 2, these are the possible strings. Of these possible strings, the one which we are interested in or the one which met our condition given in the questions are these two strings. Now these two strings, let us make an entry of these two strings over here. 1 0 is one string which satisfies the condition, and here the number of zeros is 0, the number of ones is 1. Similarly 1 and 1 is a valid string, and here the number of zeros is 0. I'm sorry, here the number of zeros was 1. Actually there is just there is 1 0 over here, and the number of ones in this particular case is 2. So I hope how we are populating this data is clear. We will see it in a bit that how can we optimally go ahead and populate this data, but for now let us understand the general idea that we will need this information. Now what I want to discuss here is, in order to get to this part which is 1 0 and 1 1, do we really have to generate these parts also, which is 0 0 0 1? In a sense, in order to get to our answers, do I really have to generate all possible strings of n bit? The answer to that question is no. And what we can do is we can rely on the answer of the previous string in order to generate the current string. So let us see how we can do that. So we know that for previous string n is equals to 1, the valid answer is 1, right? So this is my valid answer. Now we are looking for n is equals to 2. Now since n is equals to 2, I have a bit over here which needs to be filled. Now this bit has two options. We can go ahead and fill this bit by 1, or we can go ahead and fill this bit by 0. So this is 1 0 1 1. And then what we need to do is we need to check this particular string and these two strings to see if it satisfies the condition given in the question or not. In this case, it satisfies the condition, and that is how we have come to this position. So what I'm trying to explain here is, in order to generate the valid strings or the possible valid string, we can rely on the answer of the previous string, which is this n-1, and for n-1 for all the valid strings we will go ahead and use this technique in order to arrive to a conclusion of valid string. So now let us use this technique in order to generate the valid strings for n is equals to 3. So here n is equals to 3. Now we know that the valid string for n is equals to 2 are these two. So let's go ahead and write it down, 1 0 and 1 1. Now since n is equals to 3, so I have a position left over here. Now this position can be filled up either by 0 or by 1. So if we go ahead and fill it by 0, this becomes 1 0 0. If I go ahead and fill it with 1, this becomes 1 0 and 1. Similarly for this case also, this becomes 1 1 0 and 1 1 1. Now if we look at these four strings, this is not a valid string because here the number of zeros is greater than the number of 1, and these three are valid strings. So as you can see now, we are not going ahead and generating all possible strings of 3-bit. Rather than that, I'm using the answers of n equals to 2 in order to come to our conclusion. So these are my valid strings. So let us add the correct values over here also. So for a 101, the number of ones is how much? 2, and the number of zeros is 1. Here if you see, the numbers of ones is 2 and the number of zeros is 1. And similarly for the third case, which is 1 1 and 1, the number of ones is 3 and the numbers of zeros is 0. So folks, I hope that this part, at least how we are coming to this portion, is clear by now. Now let us see how can we optimally update these values. So let us discuss that now. So this idea is also very easy to understand, folks. Now if you see this 1 0 and 1, so 1 0 1 is something which we have arrived from this position, right? So 1 0 was the initial string and then I have added 1 to it, right? So 1 0, this, for this string the data is already there, right? So for this string the data is this. Now within this data I have added 1, right? I have appended 1. That is how I have obtained this string. So all we have to do is we have to update this value accordingly, right? So since I have added 1, so the number of 1 should get increased to 2, right? So that is what it is happening over here. So if you see this string, so let us draw a parallel between these two. So here the number of ones gets increased by 1, so that becomes 2, and the number of zeros remains intact, which is 1, right? Similarly, let us take one more example. So 1 and 1. So let us take this example, triple 1. So triple 1 we have come from double 1 string, right? This is how we have come to triple 1. So now let us go ahead and draw a parallel between these two. In double 1 I have added another 1. So because of which, if you see this data, so the number of ones should get increased by 1 and the number of zeros should remain as it is, and that's exactly what has happened over here. So the numbers of ones remains 3 and the numbers of 0 becomes 0. I hope folks by now the general idea is clear. In order to solidify our understanding, let's take one more example and then we will discuss how we will go ahead and code this. So now let us take the case where n is equals to 4. So in order to generate the valid strings for n is equals to 4, we can rely on the solutions of the previous, which is this. So let's use that. So now we have 101, double 10 and triple 1. So let's use that. And in all the cases I have position left over here. Now all these things can be, we can go ahead and fill it with either 0 or 1. So let's go ahead and do that. So these are the cases, right? So for all these cases, now let us go ahead and discuss the valid and invalid string. So this is a valid string. This is also a valid string. This is a valid string. These, it turns out all the strings are valid strings. Okay. So now let's go ahead and populate this information in our answer dictionary. So for 1010, so remember here 1010 has come from where? 10 and 1. So let us use that information. So this is my 101. This contains the information about 10 and 1. And here, since I have added over 0 here, so if you see this, since I have added 0 over here, so what should happen here is the number of zeros should get increased by ones and the number of ones remains as it is. So we will go ahead and do that. So here the number of ones is 2 and the numbers of 0 should get increased by 1, so that's become equals to 2. Similarly for the other cases, 1 0 1 and 1. So for this case also, since also this also relies on 1 0 and 1, so 1 0 and 1 we have this information with us. Here the number of ones will get increased by 1 because we have added 1 over here, so it will get increased by 1 and the number of zeros should remain as it is. So the number of ones should get increased by 1, so that becomes 3, and the numbers of zeros remains as it is, so that is 1. And similarly we can go ahead and populate for the rest of the case. So that's the general idea, folks. Now let us see how we will be able to code this. So in order to code this in Python, we will use a DP table, and this is a of type dictionary. And over here what we are going to do is we are going to store the answer for the first case, which is my base case. For n is equals to 1, the valid string as we know is just 1, and within this valid string the number of zeros is 0, and similarly the number of 1 for this valid string is 1. Let me just do a quick recap over here, folks. So this is my dictionary, this is n is equals to 1. These are the valid strings for that dictionary. So for valid strings, since there is just one valid dictionary, so that is how it is just 1. And within this valid string, what is the number of zeros here? So the number of 0 is 0 and the number of 1 is 1. Sorry folks, this is 1. Now what we are going to do is we are going to iterate for, so for I in range of 2 to n plus 1. So first thing which we would like to do is dp of I is equals to dictionary. So we want to create this dictionary. So folks, as you can, I have taken a little bit of shortcut over here, but if you want to do it correctly, then first you have to say that dp of 1 is equals to dictionary, and once you have this, then again you have to say that dp of 1 and this one is again a dictionary, and then eventually you are going ahead and for key 0 you are putting a value of 0, and for key equals to 1 you are putting a value of 1. So that's why I am saying that dp of I equals to dict. Now let us first have my previous answers over here. So previous dict, so since I equals to 2 and I equals to 1 entry is already there, so I'm going to go ahead and use dp of I minus 1 here. So I'm keeping that value in previous dict. Now in the previous dict, all the valid strings are there in the key. So what do I mean here is, so I equals to 2, so we are relying on I equals to 1, and in I equals to 1 the valid strings are these, right? So this is my valid string, so that is what I am trying to iterate on the valid strings in previous dict dot keys. Now once I have the valid string within me, I will go ahead. So now let us say I equals, so for I is equals to 1, the valid string as we know is 1. So now this position is vacant for us, and in this position I have two options. Either I can go ahead and populate it with 1, or I can go ahead and populate it with 0. So first let's go ahead and populate it with 1. So if we are going to check previous dict key, and here let us get the number of ones. So this will give me the number of ones which we have for I equals to 1, and then I'm going to go ahead and add 1 to it. So here this is 1 and 1 case I'm discussing here. In order for this to be a valid string, so the number of ones should be greater than or equals to the number of zeros. If this is the case, then this is a valid string, and we are going to make an entry of the valid string in our dictionary. So let's go ahead and make a entry over here. So dp of I, the valid entry is this key, and the key will be appended by 1. So this is my valid string, and now in this, for this valid string I want to store this information, that what is the number of ones and what is the number of zeros. So let's go ahead and do that. So the number of ones will get increased by 1, this part. So let's go ahead and use this part, and the number of zeros remains as it is. So let's go ahead and fill that information. So this was the case when we have appended 1 over here, but we can also go ahead and append 0 over here, right? So now let us go ahead and discuss that case. So here again the condition should be my number of ones should be greater than or equals to the number of zeros. So let's go ahead and check it. If previous dict key, okay, and here let us say the number of 1 is over here, this should be greater than or equals to previous dict key, the number of zeros, and since we are adding one more 0 over here, so plus 1, it should be greater than or equals to 0. Then the condition is satisfied, and then we have to make an entry in dp table. So dp of I, and what is the correct string here? So key plus, and we have added a 0 over here. This is my valid string, and let's create a dict. And for this string, let us now populate the values of number of zeros and 1. So the number of ones remains as it is, since we have not altered the value of number of ones, and the number of zeros gets increased by 1. So let's go ahead and write it, previous dict plus 1. And then towards the end, what we are going to do is we are going to return dp of n. So we want to return for n and keys. So this contains all the valid answers. So that's about the general idea of how we are going to implement it in Python. Now let us look at the actual code for this. So the actual code is pretty much the same what we have discussed over here. A little bit of changes is also there, and I'll walk over those changes. So the first thing I have done is a dp table, and dp of 1, this is my base case. So this is a dictionary. For dp, for n is equals to 1, the valid string is 1 itself, right? And in this valid string, the number of zeros is 0 and the number of 1 is 1. So that info, so these many information for n is equals to 1 is there in our dp table. I'm also using an answer. So let us first go over the logic first, and then we will look at what really is answer and why do we have to use answer. For now, let us skip answer. Now we are iterating on I equals to 2 to n plus 1. For dp of I need to make, we have to make an entry in the dp table. So dp of I equals to dict. For I minus 1, the previous results I am keeping in previous dictionary, and now I am iterating on previous dictionary. So the previous dictionary dot keys contains all the possible or all the valid strings for I minus 1. And now if in the previous possible answer, so this is the previous possible answer, if I go ahead and add 1 to it, right, append 1 towards the end, whether that forms a valid string or not is something which we are checking by this logic. If it forms a valid string, then key plus 1 becomes my valid string for dp of I, and we are making an entry over there. And once we have made this entry, we would like to also populate the number of ones and zeros. So that information is something which we are populating it over here like this. Please note here I have increased the existing value by 1 because here I have added 1 to my previous correct answer. Similarly, it might be possible that I could also go ahead and append 0 towards the end, and I still will get a valid answer. So that is what I am checking over here. The number of ones is greater than or equals to the number of zeros plus 1. Here the number of zeros is getting increased by 1. If that forms a valid combination, then the same information is something which we are appending over here. And this is something which we are going to do for I equals to 2 to n plus 1, and then towards the end we will go ahead and return our answer. So that's about the general code, folks. Now let us look at the answer part. This answer part is something which we only need because we have to return our answer in decreasing order of magnitude. Okay, so what I have done here is the answer part contains the answer in decimal format. Okay, so see, this is the valid string which we have. I have converted this valid string in decimal format and I have kept it in answer dictionary. Similarly over here also I have kept it in answer dictionary after converting it into decimal part. Once I have done that, then I have sorted it in decreasing order. And once I have sorted it in decreasing order, then I have converted that back to binary format, since we have to return our answer in binary format, and then I have returned answer binary. So that's about the code, folks. Now let us go ahead and submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.